What's up everyone? Welcome back. Patrick here. Moving on to the next video, we're still going to be talking about acceptance and rejection regions, but we're now going to be relating it to a bunch of concepts. So confidence, significance, power, type 1 and type 2 errors, and then all of these concepts, they're all actually interrelated. So there's going to be a bunch of new topics, a bunch of new concepts covered in this video, plus previous concepts that we've covered already. So when I'm making this video here, I'm assuming that you've gone through all of my videos on the site up until this point. There's going to be lots of carryover, so make sure you've watched all of those before watching this one, because there's going to be a lot going on in this specific video. So as a quick little review on the side, if you remember from the type 1 versus type 2 errors video, we had two decisions that we could come up with in hypothesis testing. We could either fail to reject the null or reject the null. Fail to reject the null, another way of thinking about that is accepting the null. So these are the two decisions we can make, and then we came up with scenarios of what the underlying actual reality is. So either the null is true or the null is false in both of the decisions that we make. And remember, if we accept the null or we fail to reject it and the null is true, that was a correct decision. If we fail to reject it but it's false, then that was a type 2 error. Here, if we reject the null but it's true, that was a type 1 error. And then over here, this was a correct decision. And we kind of related it to how court works. So a type 2 error, that's like a wrongful acquittal. Type 1 error, that was like a wrongful conviction. Well, what we can actually do is we can take this visual representation and sort of rearrange it. Actually, lots of times textbooks or different profs will show this in a bit of a different format. So instead of having the decisions up here, they'll actually have their two different realities up there. So for example, the two different realities is either the null is true or the null is false. And then the two branches will be the two decisions that you can make. So you could either fail to reject the null, that's like accepting the null, or you could reject the null. Same thing here. The null can be false, and you could do one of two things. You could fail to reject, or you can reject it. Right? So it's the same scenario, just sort of rearranged. And lots of times you'll see it in this kind of format. Even these branches sometimes will be shown like sideways. So you'll have like H is true, and then you'll have either accept the null or reject it. Right? Sometimes it's shown like that. I'm just going to keep it in this fashion over here. So going through these, if the null is true and we fail to reject it or we accept the null, then that's a correct decision. Right? That's like this over here. Failing to reject and the null is true. Now, if we reject the null when it's true, then that is a type 1 error. So this here is a type 1 error. If we fail to reject the null or we accept the null when it's false, this is a type 2 error. And then this here is a correct decision. And so in this video, I'm actually going to be using this visual representation, because the way I'm going to explain stuff is just going to be easier to see. I can use this one as well. It doesn't really matter. It's just, it's not going to be as smooth visually. It's going to be a lot easier for you to see visually what's happening with this diagram over here. Now with each of these four scenarios here, we're going to be assigning actual probabilities to them. I sort of mentioned this a little bit in the type 1 versus type 2 errors video, but we didn't go into full detail. So we're going to be assigning probabilities to each of these. And so what I want to do is start off with this type 1 error here. So the probability of making a type 1 error, it's represented by this symbol alpha over here. It's called the significance. Right? So the significance level of a hypothesis test, it's just the probability of making a type 1 error. Or if you want to write this more specifically, you could say the probability of rejecting the null when the null is true, which is a type 1 error. Remember this, if we relate it to the court example, I'm going to be bringing back this example a lot, just as a heads up in this video. It's like a wrongful conviction. Right? You're saying someone's guilty when they're truly not guilty. So if this branch over here has a probability of alpha, then because there's only 2 branches, both of these have to add up to 1. We know that this branch is going to have a probability of 1 minus alpha. So the probability of this happening is 1 minus alpha. And when we make this correct decision, and more specifically when we fail to reject the null, given that the null is true, that this probability of this happening is called the confidence level of a hypothesis test. Right? So the confidence level, it's not just the probability of making a correct decision, because we could also make a correct decision over here. More specifically, it's the probability of failing to reject the null or accepting the null when the null is true. Right? So that's how this part works when the null is true. 2 scenarios that could happen, 2 decisions, probability alpha, probability 1 minus alpha. Now over here with these branches, the probability of a type 2 error it's given by this symbol beta here. Now over here there was a name for this. We called this the significance level of the hypothesis test. This doesn't really have a name. It's just represented by beta. Sometimes you'll see it called beta risk. And it's just basically the probability of making a type 2 error. Or more specifically, the probability of failing to reject the null when the null is false. So we're accepting the null, but it's really false, right? So this was like a wrongful acquittal. Just as a quick review. Right? So we said someone is innocent when really in reality they were guilty. And then the last branch, this correct decision that could be made, okay, so if this is a probability of beta, then this is going to be a probability of 1 minus beta. Right? So this is a probability of 1 minus beta happening. And the probability of this branch happening is called the power of a test. So the power of a test, it's the probability, not just making a correct decision, but more specifically, the probability of rejecting the null when the null is false. right? So two types of correct decisions we can make. And the probability of each are described differently. This is called the confidence level. This is called the power of a test. Now, what I'm going to show you soon in this video is that these two, type 1 and type 2 errors, they actually have an inverse relationship. Their probabilities have an inverse relationship. So when you decrease the probability of this one, you actually increase the probability of this one, and vice versa. But then also notice that there's an inverse relationship between these two, right? Like if you increase this alpha, this probability, then you're going to decrease this. Or if you decrease this, you're going to increase that. Same thing with these branches here. So for example, let's say we want to increase our probability of making this correct decision. So we want to increase our confidence level. Well, that's going to decrease the probability of a type 1 error, which is good. Problem is it's going to increase the probability of a type 2 error. Same thing over here. If we want to increase the probability of making this correct decision, so increase the power of a test, that's good because it's going to decrease the probability of a type 2 error, but because these have an inverse relationship, we're actually going to increase the probability of a type 1 error. So to finish off the video, I'm going to describe the differences between high confidence and high power and how they relate to acceptance versus rejection regions in hypothesis testing. And I'm actually going to do this through an example that's going to be a little bit out there as a heads up. It's actually going to be the court example. Again, I'm just going to be going into a little bit more detail. And when I'm describing the example, the scenario, initially you may think it's a little bit weird, but if you follow through to the end, you'll see that it's pretty intuitive. And it should help you remember. This is actually how I personally like to remember all of these concepts and how they come together. And so high confidence, high power, as we saw on the tree, it's two different correct decisions you can make with hypothesis testing. And so what I want you to pretend is like you're a judge in court. And you're either going to be a judge of high confidence or high power. So if you're a judge of high confidence, we showed that the probability of making that correct decision was 1 minus alpha. And if you want to have high confidence, that means you're going to have less type 1 errors, right? As we saw on the tree. So you're going to have less wrongful convictions, right? So less type 1 errors. Versus if you're a judge of high power, the probability of making that correct decision was 1 minus beta. And if you want higher power, then you got to have less type 2 errors on that tree. So you're going to have less wrongful acquittals. Right? So another way of looking at this is you want to catch more criminals as a high power judge. And so you want less type 2 errors, right? Less guilty people being set free. So they're kind of similar, but they're actually different paradigms. Here, you're more so concerned about protecting the innocent, and here, you're more concerned about catching the guilty. They're two different focuses. So let's talk about this high confidence column over here. So let's talk about if you're a judge of high confidence, you want to have less wrongful convictions. So what that means is that you want to be very, very, very certain before you send anyone to jail that they are guilty. And so how can you increase that confidence before convicting them? Well, you can accept only the highest quality type of evidence. And the highest quality type of evidence that comes to my mind is video evidence. So you would only accept video evidence. Any other evidence to you would not be good enough. So fingerprints, witnesses, for you that would be too wishy-washy. You need to see video evidence. You need to see a video with someone's face clearly on it committing the crime before you send them to jail. Now, it's impossible to have 100% confidence because even if you have a video of someone committing a crime, there might be some kind of background scenario that you're unaware of, right? Maybe they're doing it in self-defense. Maybe in the video the audio was muted, so you don't get the full kind of details of what happened. But most times, video evidence, you see someone committing the crime with their face on it, you could be more confident than not when you're sending them to jail, when you're convicting them. And so there's going to be less wrongful convictions then when you're only accepting video evidence. But what is the issue with this strategy over here? The issue with this strategy is that you're ignoring all other evidence, right? So for example, let's say there's no video evidence of a robbery happening, but let's say that there are 10 witnesses that saw someone go into a store and rob the store and then leave the store in a car, and then those witnesses have no bias, so the witnesses don't know each other and the witnesses don't know the person who robbed the store. They all saw him go in, rob the store, get out, drive off. And when you're presented with that kind of evidence and you're a high confidence judge, yeah, I don't want to hear witnesses. I want to see a video. I want to be fully confident in knowing that this person committed the crime. So you're ignoring all other evidence. So you're doing less analysis. In this case, the trial is less important, right? As a high confidence judge, you only want to see video evidence. And so that's an issue because if there were 10 witnesses that saw someone go and rob a store and you let this guy off, then notice that that is a wrongful acquittal, right? So there's going to be more wrongful acquittals because you're ignoring all other kinds of evidence. You're not looking at all the trials that you really should look at because you're only concerned with seeing this such high quality type of evidence that is not always going to be there. And so the issue is that there's going to be more wrongful acquittals. So that's why there's that trade-off there. So there's going to be more type 2 errors. And so that's how it works. So if you're focusing on minimizing type 1 errors, focusing on less wrongful convictions, then there's going to be more wrongful acquittals. So there's going to be more type 2 errors. And that's that inverse relationship between type 1 and type 2 errors that I was talking about. And this is a more intuitive way to kind of look at it, to relate it to a scenario so you can file it in your mind a little bit better. So I'm actually going to erase a portion here so I can give myself more room. So issue, more wrongful acquittals. Not 2 C's, 2 T's. So more type 2. And so with hypothesis testing, so now we're bringing something totally out of left field. We talked about that acceptance versus rejection region. In this kind of scenario where you have high confidence, the acceptance region is going to be very large, or that non-rejection region. Right? And so that rejection region, or that critical region, is going to be a lot smaller, right? Because there's going to be less convictions in general. And actually these two, so this is like, remember confidence intervals, right? The higher the confidence, the larger the interval. Same sort of thing with hypothesis testing. The larger the confidence, the larger the acceptance region. And then the rejection region, these two, they add up actually to, let's maybe put arrows here, to that significance, to that alpha. And so in this kind of scenario, we just have a more acceptance of that null, less rejection of that null, right? And so that's how all of these relate to acceptance versus rejection regions. Now, let's talk about if you're a high power judge. So you're focused on less wrongful acquittals. You want to catch more criminals. Well, it's going to be kind of the opposite of this. You're not only going to be accepting video evidence, but you're going to be looking or accepting all evidence. Right? So you want to see all evidence, you want to see all the trials, you want to just make sure that there are no criminals in the public. You want to catch as many criminals as you can. But the issue with this kind of strategy is what? Is that you may be looking a little bit too much. So someone may claim that someone else robbed their house, but there's no witnesses, there's no video evidence, there is no fingerprints. But because someone just claimed that, it still has to go to court. Because you're a high-powered judge, you're accepting all kinds of evidence. And then when it goes to court, there may be some kind of bias that comes up. The person who's innocent, who didn't actually rob the house, they may not know how to defend themselves in court properly. And so the issue with this strategy is that there's going to be more wrongful convictions. So there's going to be more type 1 errors. And so that's the trade-off, right, between type 2 errors and type 1 errors. If you're focusing on less type 2 errors, you're going to get more type 1 errors, right? And then same thing here. If you're focusing on less type 1 errors, you're going to get more type 2 errors. And those are two different scenarios where it intuitively makes sense. So what's good about this strategy versus this one is you're going to catch more criminals, right, in this strategy versus this one, but you're also going to have more wrongful convictions in this strategy versus this one. And so the way this looks like in hypothesis testing is that the acceptance region is a lot more narrow, right? Because anything can go to trial. So everyone has a chance, a high chance of going to trial for something. Even if there's just only a claim that you did something, it's going to go to trial. And so less of an acceptance region, so less acceptance of the null hypothesis or of that innocence. Remember, null hypothesis always assumed innocent before proven guilty. And there's going to be more rejection, more convictions. Right? That rejection region or that alpha, that significance level is going to be larger. right? So that's if you're increasing the power of a test, that acceptance region is getting smaller. And actually, what I want to bring back from the previous video, if you remember, the sample, increasing the sample size does the same thing. Remember, when we increase the sample size, that acceptance region gets more and more narrow. And so actually increasing sample size increases power of a test. So that's kind of how that other video relates to this as well. And you could think of increasing sample size like increasing evidence. And so that acceptance region, again, it gets more narrow in both scenarios. So that's how those two relate. And that's pretty much it. One more thing I actually want to mention is this alpha here, this significance level. If you remember with confidence intervals, we were given the confidence percentage. And so that affected how large, how wide, or how narrow that confidence interval is going to be. But with hypothesis testing, a lot of times you're not given the confidence percentage, you're going to be given this instead. So you're going to be given these probabilities over here, right, which is alpha. So just thought I would make a note of that, but we will see that in future examples. Anyway, so that's it for this video. I know it's a lot to take in, a lot of concepts we covered. Hopefully it made sense through the example that I presented, and hopefully it allows you to remember all of this stuff easier.